programs and its website by the hosts, guests, and call-in listeners or chatters are solely the
Hey everyone, you're back with David Mackey's Shiny Side Out on Revolution Radio, on the #1 listener-supported talk radio on the net. So, push the donate button and subscribe to the archives for free. You can do that. Get yourself some great merchandise from the station's website. You can get a t-shirt, maybe a mug or anything like. We also sell merch, so check our links below for those and all the platforms you'll find us on. And I'm going to thank you for listening to Revolution Radio. We're halfway through show number 697. We're almost at the 700 mark. That's a month away. Big show, that one. Whenever we have a show that has 2 zeros at the end, like show 100, 200, 300, etc., this will be show 700. When we get to this, it's a big show. We ask the station to block out an extra 2 hours behind the show so we can do a 4-hour show or something like that. We like to go through all the things that we've now discovered and put together, pieced together like a jigsaw. When we first started, there weren't that many pieces in the jigsaw. As we've gone on, every 100 shows, we've found more pieces, and the pictures are now beginning to be seen, to be discovered. Like if you're doing something like a jigsaw puzzle, you place some pieces down, and it doesn't totally reveal what you're looking at. And as time goes on and you place more pieces, this is what's happening. We're seeing more and more with clarity these connections between everything. And how does it all fit together? And we've evolved a view on what's truly happening in our world. So do stay tuned for that. It's a month away, show 700, or thereabouts, a month away. But keep tuned, and we'll talk you through that when we get to it. So Mackey's off because he has he's got the tail end of virus, and when he comes back at the moment, he can't say any words without coughing. I'm on the other end of that. While I didn't have the same virus, I just have this cough. It just doesn't seem to go away. And every once in a while I have to clear my throat, and I can't even reach for the button. It's such an automatic response that I'm incapable of being able to respond fast enough to it. So, and mind you, I am trying to repress it as much as possible. So, sorry about that. We're talking about ET's rational and logical approach. This is part 2. There is a part 1. Oh boy. I'm just sorry. I just glanced over at the chat room, and Jim Jones is certainly having a big discussion there. I'm not going to say rant, because that's kind of inappropriate. Good on you, Jim, whoever you are. It's probably not your name, but I'm okay with that. It says, one of the quote parts from it is, quoted line, "Free yourselves and establish freedom where you live. Spectators, critics who can't do what you preach, hypocrites living without the rights we enjoy every day." Yes, absolutely, 100%. That's what he said. Now, this is show 697. I'm going to continue. This is part of the Drake equation conversation. If you're not aware of the Drake equation, I'll put it on the screen Let me show middle screen. I do have a few screens. And you can see here, n. No, where's the actual equation? Oh, it's quite long, but these are all the factors. So the number of civilizations in our galaxy with which communication might be possible, i.e., are on our current past light cone. So now here's the criticism. Criticism of the Drake equation follows mostly from the observation that several terms in the equation are largely or entirely based on conjecture. Star formation rates are well known, and the incidence of planets has a sound theoretical and observational basis, but the other terms in the equation become very speculative. The uncertainties revolve around our understanding of the evolution of life, intelligence, and civilization, not physics. Not physics. Wow, sorry guys, just saying. There's some sixes popping off near Japan right now. 6.7, 7.4, 5, 6.6. So I'll do this so you can see. So there's a few popping off here. And I'm going to minimize that. Now, where was I? No statistical estimates are possible for some of the parameters, where only one example is known. The net result is that the equation cannot be used to draw firm conclusions of any kind. This is the critic's perspective. And the resulting margin of error is huge, far beyond what some consider acceptable or meaningful. One reply to such criticisms is that even though the Drake equation currently involves speculation about unmeasured parameters, it was intended as a way to stimulate dialogue on these topics. Then the focus becomes how to proceed experimentally. Indeed, Drake originally formulated the equation merely as an agenda for discussion at the Green Bank Conference. So, firstly, the Drake equation. How many current civilizations can emit right now a detectable radio signal into space that we can pick up? Is the net outcome of the Drake equation. If you fall out a little earlier before that, you get the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And then the last one obviously is the time it takes for that detectable signal to hit us. So if you drop those two off, you have the fraction of planets with life that actually go on to develop intelligent life, like civilizations. That's the most important number. Whether or not they broadcast anything stupidly into space like we did is another point on its own. So if we only looked at the average rate of star formation in our galaxy, that's all related to our galaxy, the fraction of those stars that have planets, the average number of planets that can potentially support life per star that has planets, the fraction of planets that could support life, that actually develop life at some point. And the one that I'm interested in here is the fraction of planets with life that actually go on to develop intelligent life. Whether or not they make a technology that broadcasts is irrelevant. That's only for the SETI program. So what could we detect coming from there? And that detection rate and scope also depends on how far away they are from us because of time it takes for those signals to reach us. So there's quite a very broad range of time frames here, because they could be 100 years ago or 100,000 years ago. It just depends on where they are according to how far away they are, because it's just a measured amount of speed. That's it, time, and then we'd know where they were. Anyway, the point then is, well, if the number that falls out of the Drake equation is such a large number, then where are they all? And that's the Fermi paradox. The civilization lasting for tens of millions of years could be able to spread throughout the entire galaxy. We've done simulations that prove that even we could do that, even with our horribly insufficient technology, like rocket engines. We could still, in tens of millions of years, still populate the entire galaxy. Isn't that amazing? However, no confirmed signs, confirmed in air quotes, signs of civilizations or intelligent life elsewhere have been found, either in our galaxy or in the observable universe of 2 trillion galaxies. Okay, that's good on you for going against what that means. And the word confirmed there is the most important word in that phrase. So, on with the notes. According to this line of thinking, the tendency to flip up or at least explore all available territory seems to be a universal trait of living things. So Earth should have already been colonized, or at least visited. But no evidence, yet again air quotes, no evidence of this exists. Hence, Fermi's question, where is everybody? I'll get into what I think at the end of reading the Fermi paradox on its own. A large number of explanations have been proposed to explain this lack of contact. A book published in 2015 elaborated on 75 different explanations. In terms of the Drake equation, the explanations can be divided into 3 classes. Number 1, few intelligent civilizations ever arise. This is an argument that at least one of the first terms are F, P, N, E, F, I, or big I, F, little I, has a low value. The most common suspect is F, little I, but explanations such as the rare Earth hypothesis argue that NE is the small term. And if I go back and I explain, NE is the average number of planets that can potentially support life per star that has planets, and F little I is the fraction of planets with life that actually go on to develop intelligent life. So which of those two is the small one? It's remarkable. People will question everything down to the nth and then ignore anything that current law has, just so that, well, we're all in lockstep, aren't we? I get my grant, don't I? Still, if I say no, then I still get my grant, right? Point 2. Intelligent civilizations exist, but we see no evidence. Meaning FC, which is the fraction of those stars that have... No, FC is the fraction of civilizations that develop a technology that releases detectable signs. So the fact that we can't see them is meaning intelligent civilizations exist, but we see no evidence, meaning that FC, they're not broadcasting, is small. Typical arguments include that civilizations are too far away or too far apart, or it's too expensive to spread throughout the galaxy. And once again, expensive. We're the only planet on the in the whole universe that has money. Maybe people don't have money. Maybe they didn't have greed. Maybe they work like an ant colony where everyone just thrives, and the mission is not yours to determine. Possibly civilizations broadcast signals for only a brief period of time. Communication is dangerous, possibly. Imagine if this was a post-apocalyptic world and you lit a fire to cook some food and you were amongst the hungry, you would be inundated with hungry people. So that fire being a radio signal, if there were such fighting hordes that would rob you of your technology, if you play, or what's that, Rust. If you play Rust, you don't want to ever, be susceptible to someone else's gunfire. They'll steal everything you have, and you start from scratch again. So if you were living in a very densely populated region where there were lots of civilizations and they were actively visible everywhere in the sky, and they never really popped in because you never presented yourself, and the moment you do, it's all over for you, and you're either assimilated like they were the Borg, or that's funny, or they held you back. Maybe there was an active way of being able to hold back civilization, so you would never become a threat to them, because you could do that too, right? So that's possible. And then the third point is the lifetime of intelligent communicative civilizations is short, meaning that the L is small in the Drake equation. Drake suggested that a large number of extraterrestrial civilizations would form, and he would further speculate that the lack of evidence of such civilizations may be because technological civilizations tend to disappear rather quickly. Typical explanations include it is the nature of intelligence to destroy itself. It is the nature of intelligent life to destroy others. They tend to be destroyed by natural events and others. So you end up in a new world of threats. Starting to broadcast yourself is just advertising that you've got tech, and that could be bad. I think humanity has already advertised itself tenfold or 100-fold by setting off 2,000 nuclear explosions in our area, either terrestrially, underground, or in the air, or in space, or underwater for that matter. And each of those, if the multiverse is a thing, if it turns out to be provable and not speculative, if a nuclear explosion destroys matter in all of those multiverses that currently overlap with each other, then we've announced ourselves to possibly even an infinite amount of species. I would suggest that possibly there's always been people here. This is the tinfoil hat bit. Or they arrived here after the first nukes, which I don't believe. I think they're already here anyway. Or maybe we were just on, the very low transited area of space, and because we didn't have tech, maybe the prime directive is that you stay away from primitive species. You try to be hidden. You don't advertise yourself to them. It just never turns out well. You'll end up being one of their gods, and they'll, because of that, I'm speculating, that they develop religion rather than science to drive them forward. Imagine if we didn't ever have a religion. Could you imagine what the repercussions of that would be? If it were, as I'm speculating, that religion is a deterrent for science, because for so long people, I'm looking at you, Galileo, were persecuted for going against Scripture. The Earth isn't the centre of the universe. If that was immediately accepted, we'd already have 200 years start, or 400 years start on our science, because it would have been accepted. Oh, really? Can you make a model? Yeah, I made a model. Look, it's working now. And I can tell you what's going to happen next. And look, I'm right. You know, planets going one way, then stopping, and then kind of doing a little loop, and then coming. That was what Mars appeared to be from the Earth's perspective. And they couldn't, there's no model that could make that work. But having us go rotate around the sun, and we catch up on Mars, and then as our orbits differ from each other, then it seems to stop in the air, go back as we rotate around the sun, and then starts on its way again. Does that make, I hope it makes sense to you. It does a little loop in its full orbit. And that wouldn't be possible. It just isn't possible with the Earth in the middle. None of that makes sense. And the heavy mass of the sun orbiting around our little planet is ridiculous. Completely ridiculous. It would perturb our orbit so much, our center of, spin, by, 1 million kilometers or more, 1 million Earth widths, and all the other planets would have a hard time trying to stay rotating around us if we were getting thrown about so readily by the sun's mass. See, none of that makes any sense at all. Flat Earth, ridiculous. Earth, the center of the solar system, ridiculous. Center of the galaxy, even more ridiculous. With the 2 trillion galaxies orbiting around us, it's ridiculous. So, the notions that were put forward, that in my speculation here, that religion holds back science, is if the two options were available and we took religion because someone had visited us, let's say, for an example, using the cargo cult method of religion. So, it's Venus, not Mars. I thought it was Mars too. Yeah, not the figure 8 one, the one that does a very small loop, Becky. So, if the cargo cult thing is real, because it is from World War II, then anyone visiting with such technology, so many steps away, everything appears like magic, and they'd be gods with a significant amount of gap in technology. So, yes, that would make sense. We would be pursuing them as gods rather than a destination of technology to achieve. I think that idea is a valid one, that pursuing technology without religion would have got us to a higher state of technology far quicker. It would have us arguing less as a people on Earth if we were all going in one direction, but at the moment we're all tugging at like a knotted rope, each of us holding a separate end, trying to drag ourselves in different directions. That too is ridiculous, and usually towards a big pile of money, because that's where all of our inventions are funded. They're all funded by money, everything costs money, and only things that have any true value resale-wise are the ones that are pursued. So think about all the inventions that weren't pursued because there was no money in making it, but could have led to a furthering of our technological stance. I wonder that all the time. So, let's say that these lines of reasoning about those 3 points led to the greater filter hypothesis, which states that since there are no observed extraterrestrial civilizations despite the vast number of stars at least one step in the process must be acting as a filter to reduce the final value. According to this view, either it is very difficult for intelligent life to arise, or the lifetime of technological advanced civilizations, or the period of time they reveal their existence, must be relatively short. An analysis of Anders Sandberg, Eric Drexler, and Toby Ord suggests a substantial ex ante probability of there being no other intelligent life in our observable universe. And that's the most preposterous analysis output that I've ever heard in my entire life. That is where they came to. That's their outcome. So what I was trying to suggest earlier with those 3 points, the first point is that life is rare in the universe. The second one is that there's no evidence of any civilizations anywhere, and certainly none have tried to communicate with us, and there's no evidence, yet again, lack of evidence of such civilizations, because they tend to disappear. How about let's not anthropomorphize it? Why don't we kind of alienize it and say, well, they have a prime directive, they can't come anywhere near us, number one. It ruins the civilization should we turn up somewhere. So we're flying through space and we find some cave people and go, you know what, you can start farming straight away. And then they, instead of farming after we've left, they recreate copies of our spaceships and just do cave paintings showing us with watches and things like that on our wrists and skin-tight suits with no seams. Because that's what we find on the Earth. We've been to Space Rock, Meccy and I. We've seen it. There's a carving from then by the Aboriginals saying they were visited by these people. There's even like the ones that are surrounded by like white light. Extraordinary. So if there's no evidence at all that any civilizations have ever visited us, then this makes no sense, once again, because there's stuff flying around in the sky that doesn't appear to be ours. There are documents redacted up to the hilt where the entire page has been, blackened out. You can't read any text on it. And this is a UFO release saying nothing about anything. How can that even be? I believe that after our first nuke, we were visited, but only to our government. They did some flybys of warnings, but just to get their attention. And that worked. And they signed a thing for them to live in the Southern Ocean. That's kind of where I'm leaning. And therefore, everything in the sky is an unspoken thing. Everything in the sky, after we started to reverse engineer everything, was simply Project Blue Book, just to see what people were seeing in the sky. Not looking for aliens, but looking for anything that we might be flying that is ours, that's secret. Because, everyone will report anything. And then we ended up with all these excuses, migrating geese, inverted swamp gas. Just ridiculous. All these Venus, it's Venus. Like Meccy said in the chat room when I was talking about Mars, he goes, it's Venus. So everything tends to annoy me about where we're at in here. But the answer, back to the show notes, the answer to Fermi's paradox might simply be that we cannot perceive them because they might be too advanced or simply too different for us to recognize as sentient life. It also is feasible that they do not wish to interact with us because either they do not want to do it, to understand the need to, or might even be guided by some kind of prime directive. That, of course, is complete speculation, as we have no way to imagine how a truly alien life form might reason, or if reason even comes into it. Maybe they only live in water. Flying in space would be tough. Like that, like the one where that spaceship comes down and it's got like tentacles. Lives in a fish tank. Flies around in a fish tank. In 1964, Nikola Kardashev, a Russian astrophysicist, proposed a scale by which to measure a civilization's technological achievements. And this is the Type 1, Type 2, Type 3 civs. A Type 1 civilization, also called a planetary civilization, can use and store all the energy available on its planet. A Type 2 civilization, also called a stellar civilization, can use and control energy at the scale of its planetary system. And a Type 3 civilization, also called a galactic civilization, can control energy at the scale of its entire host galaxy. At this scale, our current civilization would be a Type 0, meaning we are not even on the scale. A Type 2 civilization, for example, would be able to build a Dyson sphere. But you know, the Dyson sphere would probably be to the detriment of everything else in the solar system. So, would you? I think there's many more. There's probably 5 points between each one of these. Considering the assumed age of the universe at 13.7 billion, I argued that it's probably 100 times that, billion years, and our Earth is meant to have only been around for 4.5 billion of those years, it seems almost staggeringly implausible to assume that there are no Type 1, 2, or even 3 civilizations out there. If there are Type 2 and Type 3 civs anywhere in this galaxy or neighbouring galaxies, then we might simply be too primitive to understand what we are seeing when we are looking at their monuments, such as Dyson spheres, black hole engines, sun clusters or ornaments, and the like. The next part here is a new study estimates the odds of life and intelligence emerging beyond our planet. This is from May 18th, 2020, Columbia University. And the summary says, despite knowing when life first appeared on Earth, scientists still do not understand how life occurred, which has important implications for the likelihood of finding life elsewhere in the universe. A new paper shows how an analysis using a statistical technique called Bayesian inference could shed light on how complex extraterrestrial life might have evolved in alien worlds. Humans have been wondering whether we are alone in the universe since antiquity. We know from the geological record that life started relatively quickly as soon as our planet's environment was stable enough to support it. We also know that the first multicellular organism, which eventually produced today's technological civilization, took far longer to evolve, approximately 4 billion years. But despite knowing when life first appeared on Earth, scientists still do not understand how life occurred, which has important implications for the likelihood of finding life elsewhere in the universe. In a new paper published in the Proceeding of the National Academy of Sciences today, David Kipping, an assistant professor in Columbia's Department of Astronomy, shows how an analysis using a statistical technique called Bayesian inference could shed life. That's a Freudian slip. could shed light on how complex extraterrestrial life might evolve in alien worlds. The rapid emergence, quote, of life and the late evolution of humanity in the context of the timeline of evolution are certainly suggestive, Kipping said. But in this study, it's possible to actually quantify what the facts tell us, unquote. To conduct his analysis, Kipping used the chronology of the earliest evidence for life and the evolution of humanity. He asked how often we would expect life and intelligence to re-emerge if Earth's history were to repeat, rerunning the clock over and over again. He framed the problem in terms of 4 possible answers. 1. Life is common and often develops intelligence. 2. Life is rare but often develops intelligence. 3. Life is common and rarely develops intelligence. And finally, life is rare and rarely develops intelligence. This method of Bayesian statistical inference used to update the probability for a hypothesis as evidence or information becomes available. States prior beliefs about the system being modelled, which are then combined with data to cast probabilities of outcomes. Kipling says the technique is akin to betting odds. It encourages the repeated testing of new evidence against your position, in essence, a positive feedback loop of refining your estimates of likelihood of an event. From these 4 hypotheses, Kipping used Bayesian mathematical formulas to weigh the models against one another. Quote, in Bayesian inference, prior probability distributions always need to be selected. But a key result here is that when one compares the rare life versus common life scenarios, the common life scenario is always at least 9 times more likely than the rare one, Kipling said. The analysis is based on evidence that life emerged within 300 million years of the formation of the Earth's oceans as found in carbon-13 depleted zircon deposits. A very fast start in the context of Earth's lifetime. Kipping emphasizes that the ratio is at least 9-1 or higher, depending on the true value of how often intelligence develops. Kipping's conclusion is that if planets with similar conditions and evolutionary timelines to Earth are common, then the analysis suggests that life should have little problem spontaneously emerging on other planets. And what are the odds that these extraterrestrial lives could be complex, differentiated, and intelligent? Here, Kipling's inquiry is less assured, finding 3-2 odds in favour of intelligent life. This result stems from humanity's relatively late appearance in Earth's habitable window, suggesting that its development was neither an easy nor ensured process. If we played Earth's history again, the emergence of intelligence is actually somewhat unlikely, he said. Kipping points out that the odds in the study aren't overwhelming, being close to 50-50, and the findings should be treated as no more than a gentle nudge towards a hypothesis. What an out. That's a great out. Quote, the analysis can't provide certainties or guarantees, only statistical probabilities based on what happened here on Earth, Kipping said. Yet, encouragingly, the case for a universe teeming with life emerges as the favoured bet. The search for intelligent life in worlds beyond Earth should be by no means discouraged. What a way to keep everyone's money flowing. That's amazing. I wanted to stop here for a second. There is, I think it's 10,000 generations old bacteria that they've been growing and taking a sample of every day, and they feed it every day, and they take from it groups and samples of these groups, different groups of the bacteria, and they've been watching its evolution for 10,000 generations. And there's some extraordinary information coming from it. So what they did, since they've been taking samples and they've been freezing these samples, and the bacteria is more than hardy enough to survive the freezing process, they discovered that they'd been, let's say that they'd been feeding it one type of two food sources. One food source that they know that the bacteria won't eat, and another that they do. And they feed them both, and they measure the amount of both at the end of the process, whatever the scheduled process is. They discovered that for such a long time, in this 10,000 generations, that not a single bacteria ate from the food source that it's not compatible with, meaning that any that ate it died. And that's fine. They never expected what was going to happen next, and there's a branch from their evolution that allowed them to start eating the food source that they're not compatible with, and survive. They had been able to adapt to the new food source, which is extraordinary. They didn't believe they could, because they didn't have the capability. There was no capability to be able to process this new food source. But then they were able to. And what they did is they took the frozen ancestors of the group that was then able to eat from this food source, and they'd actually made the primary food source rarer and rarer and rarer, forcing it to make a choice to eat this secondary one because it wouldn't. Then they thawed out the frozen ancestors to see if without any duress that they'd still be on the path towards being able to eat this secondary food source, and they did. I think they went back 5 generations or something like that. And then they while they're genetically different from each other, they were still able to adapt to be able to eat the food source. And their genome was getting larger from the 10,000, a generation old ancestor to the current day ancestor. They were able to adapt and grow their genome and be able to learn from their environment, which was just something that they did not expect. And now back to the text. Other life, biochemical basis. Oh, and you'll be able to find that story. Just do 10,000 generation bacteria, and you'll find the story yourself. Life on Earth requires water and a solvent in which a biochemical reactions take place. Sufficient quantities of carbon and other elements, along with water, might enable the formation of living organisms on terrestrial planets with a chemical makeup and temperature range similar to that of Earth. Life based on ammonia rather than water has been suggested as an alternative. Though this solvent appears to be less suitable than water, It is also conceivable that there are forms of life whose solvent is a liquid hydrocarbon, such as methane, ethane, or propane. About 29 chemical elements play active roles in living organisms on Earth. About 95% of living matter is built upon only 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These 6 elements form the basis, the basic building blocks of virtually all life on Earth, whereas most of the remaining elements are found only in trace amounts. The unique characteristics of carbon make it unlikely that it could be replaced, even on another planet, to generate the biochemistry necessary for life as we know it. The carbon atom has the unique ability to make 4 strong chemical bonds with other atoms, including other carbon atoms. These covalent bonds have a direction in space, so that carbon atoms can form the skeleton of complex 3-dimensional structures with definite architectures such as nucleic acids and proteins. Carbon forms more compounds than the other elements combined. The great versatility of the carbon atom and its abundance in the visible universe make it the element most likely to provide the basis, even exotic ones, for the chemical composition of life on other planets. When we look with visible light into the universe, we see a bunch of pink clouds. That's hydrogen. We see clouds that are blue. I don't know what that one is, but let's hope it's oxygen, because those two together make water, and you don't need much to make water out of them. So thinking about what it is, you can burn them together and the oxygen and hydrogen will join and create water. So think about that. Carbon is any organic material that's been burnt, turns into carbon. It's carbon based, and therefore that's the output. You can only imagine, since our star is its 2nd or 3rd generation in this vicinity, or they call it suburbs, if you will, and the carbon from the previous planets here and suns or stars that have been in this vicinity, which we owe our origins to, has filled this local area with material enough. So after the first star has exploded, then there's enough material to make a whole bunch of things. But if the first star, you wouldn't get heavier elements, they would come later, for instance. So micronovas from the star, from a star, while it's still alive, can produce heavier elements. Supernovas or novas, and then supernovas, they all produce extremely heavy elements on the scale. So if we were the first gen star in our region and there hadn't been any others, we wouldn't have titanium, iron, gold, nickel, cadmium. We'd have nothing. We would just have, I don't know, rock, because bacteria can make rock. So there'd be no hydrocarbons. We wouldn't have anything. It'd be a water planet to start with, I suppose. If it was the end of the first gen star, we certainly wouldn't have anything on the planet to be able to make anything with. You need a sufficiently old region of space that's had maybe a supergiant that's gone supernova, and then clusters of small stars in its wake, in its remnants, and then those have also lived and died. And that's why I believe that the universe is very much older, because people tend to not calculate the prior stars' ages. And now that we can see further and further, once again, the argument that the universe is far older than you could possibly imagine is becoming more and more likely. Now, I think I can get through the scientific I'll do this one. So, scientific research. This is in support of this story. The scientific search for extraterrestrial life is being carried out both directly and indirectly. As of September 2017, 3,667 exoplanets in 2,747 systems have been identified, and other planets and moons in our own solar system hold the potential for hosting primitive life such as microorganisms. As of the 8th of February 2021, an updated status of studies considering the possibility or the possible detections of life forms on Venus via phosphine in the atmosphere and Mars via methane was reported. It's more likely that those are from natural processes to do with life. On Earth, all known living things have a carbon-based structure and system. Scientists have speculated about the pros and cons of using atoms other than carbon to form molecular structures necessary for life, but no one has proposed a theory employing such atoms to form all of the necessary structures. However, as Carl Sagan argued, it is very difficult to be certain whether a statement that applies to all life on Earth will turn out to apply to all life throughout the universe. Sagan used the term carbon chauvinism for such an assumption. He regarded silicon and germanium as conceivable alternatives to carbon. Other plausible elements include, but are not limited to, palladium and titanium. But on the other hand, he noted that carbon does seem more chemically versatile and is more abundant in the cosmos. Norman Horowitz devised the experiments to determine whether life might exist on Mars that were carried out by the Viking lander of 1976, the first US mission to successfully land an unmanned probe on the surface of Mars. Horowitz argued that the great versatility of the carbon atom makes it the element most likely to provide solutions, even exotic solutions, to the problem of survival on other planets. He considered that there was only a remote possibility that non-carbon life forms could exist with genetic information systems capable of self-replication and the ability to evolve and adapt. So show 698 will be the next one. Yeah, 3 minutes. Yeah, I'll leave it there. So NASA decided that they were going to fund a program to research what life would look like if the dinosaurs were never wiped out. So what would they look like today? And they spent millions on this. I could have told them. Lizard people. What I say? That's paying homage to Hagglefish. So they did a study and it just looked like lizard people. It looked like humans with lizard skin and like vertical slit eyes. That's pretty much it. They made some models of them and there was an article. You should be able to find that if you look for it. That was an extraordinary moment for me. And I kept wondering, why would they do that? Have they met the lizard people? Are lizard people real? Were they the first people to visit the US? Was there a ship that rendezvoused in the desert, like Close Encounters of the Third Kind, the movie, that actually had Hynek on at the scene when the UFO comes down, near in Wyoming, near Devil's Tower. So he was actually in that scene. You'll see him there. You recognize him. So did they actually meet lizard people? Who are the tall greys? Are they just biological, manufactured biological entities? Are they their own? Are they their own life form? Did all of these evolve independently of each other? Are they millions of years different in the evolutionary tree? Will we eventually all turn into? Will we turn into them? Is a great. I am an unprobed man, says. How's it, bro? In the chat room. There's the music. This has been Shiny Side Out with one surviving member on air and coughing, and another who's been in the chat room. We'll catch you Tuesday and Thursday morning US Eastern Time at 7 a.m. for Plato's Cave, and we'll see you next week for another Shiny Side Out with David Meckie. It'll be 698 when we get to that. And in the meantime, we asked that you stay safe.